Beneath the familiar waves that lap at shores and ripple under sunlight lies a world almost entirely alien to human eyes. The ocean, covering over 70% of Earth's surface, hides vast, unexplored realms, deep trenches, immense caverns, and alien ecosystems that remain untouched by humanity. Even with advanced submarines, sonar mapping, and robotic explorers, the majority of the deep sea remains cloaked in darkness, a silent expanse that defies both imagination and scientific understanding. The deep ocean is not merely a vast underwater desert. It is a living, breathing, dynamic world where pressures reach levels unimaginable on the surface. Temperatures plummet to near freezing, and life has evolved in ways that challenge our very definitions of survival. Giant squids glide silently in the abyss. Bioluminescent creatures light up the eternal darkness, and hydrothermal vents spew mineral-rich clouds, sustaining entire ecosystems independent of sunlight. To explore these hidden places is to enter a realm of wonder, patience, and reverence, a landscape both serene and profoundly mysterious. In this journey, we will explore the deepest secrets of the ocean, traveling from the midnight depths of abyssal plains to the volcanic chimneys of hydrothermal vents, from isolated trenches where no sunlight penetrates to underwater caves teeming with unknown life. We will contemplate the strange beauty, alien ecosystems, and quiet rhythms of these worlds, imagining the life, motion, and landscapes no human has ever seen. This is an invitation to experience the calm, reflective majesty of Earth's most hidden frontiers. Section 1. The Mariana Trench, the ocean's ultimate abyss. The Mariana Trench is the deepest known point in the world's oceans, plunging nearly 11,000 meters below the surface, a place so remote and extreme that sunlight never touches it. Descending into this trench is like entering another planet, an endless darkness where pressures exceed 1,000 times that at sea level, and the water is near freezing. It is a silent world, almost devoid of the familiar signs of surface life, yet teeming with organisms adapted to conditions that would crush humans and submarines alike. The trench itself is a narrow, crescent-shaped canyon in the Pacific Ocean, stretching hundreds of kilometers and carving the ocean floor like a colossal wound. Its slopes are steep and jagged, the walls lined with sediment and rock layers compressed over millions of years. The Mariana Trench is a geological marvel, formed where one tectonic plate dives beneath another, creating a subduction zone, a process as violent as it is ancient. Yet despite the geological drama, life has found ways to endure, quietly persisting in conditions of extreme cold and pressure. In the darkness, bioluminescent creatures illuminate the abyss with a soft, eerie glow. Giant amphipods, shrimp-like creatures, drift silently, their translucent bodies pulsing with faint light. Strange fish with elongated bodies and gelatinous structures swim slowly, conserving energy in a world where food is scarce. Each organism is a testament to evolutionary ingenuity, adapted to absorb the faintest traces of nutrition from marine snow, the constant, drifting detritus falling from the ocean's upper layers. Hydrothermal vents in the trench are particularly remarkable. These fissures spew superheated water, rich in minerals, from the Earth's interior. Around these vents, ecosystems thrive without sunlight, relying instead on chemosynthesis, bacteria converting chemicals from the vent fluid into energy. Tube worms, clams, and other vent-dwelling species cluster in dense communities, forming a fragile but vibrant web of life. It is a world entirely independent of the sun, a living reminder that life finds a way even in the most hostile environments. Exploration of the Mariana Trench is extraordinarily challenging. Even with the most advanced submersibles, dives are limited, slow, and meticulously planned. Pressure-resistant vessels descend over hours, inching through the darkness, while robotic arms collect samples of sediment, water, and microbial life. Every observation is precious. An unknown species may glide past the camera lens, or a previously unseen mineral formation may hint at tectonic processes hidden beneath layers of water and rock. Despite these challenges, the trench continues to reveal unexpected surprises. In recent years, scientists have discovered microbial life capable of surviving extreme radiation, viruses adapted to crushing pressure, and organisms that fluoresce in colors never before documented. Each discovery reshapes our understanding of life's limits and inspires awe at the quiet resilience of the deep ocean. The Mariana Trench also serves as a time capsule, preserving sediments, fossils, and chemical signatures that record millions of years of Earth's climatic and geological history. Analysis of these materials allows scientists to trace past ocean currents, tectonic shifts, and even the evolution of deep-sea species. It is not just a frontier of biology, but a record of Earth's ancient past, hidden beneath kilometers of dark water. Yet the trench is more than a scientific curiosity. It is a reminder of the planet's scale and mystery, a place that exists far beyond the reach of human influence. Its extreme isolation protects its ecosystems, allowing evolution to continue largely untouched by surface disturbances. In contemplating the Mariana Trench, one experiences a profound calm, a recognition of life's persistence in the most extreme environments, the patience of geological forces, and the enduring silence of the deep ocean. The Mariana Trench, in all its quiet majesty, is a symbol of the unknown, a dark and beautiful world where life and Earth's processes unfold slowly and deliberately. It invites reflection on the scale of our planet, the resilience of life, and the mysteries that lie just beyond the limits of human experience. No human has fully seen it, yet its presence reminds us that the deepest corners of our world are waiting, patient and serene, for those willing to explore and appreciate their subtle wonders. Section 2. The Abyssal Plains, flat, infinite, and teeming with life. Beyond the dramatic depths of trenches like the Mariana, the ocean stretches into vast expanses of near-flat, deep seafloor known as the Abyssal Plains. These plains cover more than 50% of Earth's surface and lie between 3,000 and 6,000 meters below sea level. At first glance, the abyssal plains appear desolate, featureless stretches of mud, sand, and scattered rock, stretching endlessly into darkness. Yet beneath this apparent emptiness Life thrives in subtle, quiet forms, adapted to conditions that challenge imagination and human perception. The abyssal plains are the result of eons of sediment deposition. Fine particles of silt, clay, and organic matter drift down from the ocean above, slowly settling to form layers meters thick. This sediment forms the foundation of a hidden ecosystem, a carpet supporting life that is remarkably resilient despite extreme cold, darkness, and pressure. Temperatures hover just above freezing, and sunlight never penetrates. In such an environment, survival depends on ingenuity, patience, and energy conservation. Food in the abyssal plains is scarce. Much of it comes from marine snow, organic debris, dead plankton, and detritus slowly falling from the sunlit layers above. This slow rain of life sustains a web of creatures, from tiny shrimp and amphipods to larger scavengers such as deep-sea fish and giant isopods. The rhythm of the plains is deliberate and patient. Every movement, every feeding event is calculated to maximize efficiency, conserving energy in a world where scarcity defines existence. Despite the monotony of the landscape, the abyssal plains are ecologically rich. Benthic worms burrow through sediment, recycling nutrients and creating microhabitats for microorganisms. Sea cucumbers sift the floor for tiny particles, playing a critical role in nutrient distribution. Even the occasional hydrothermal mineral deposit or underwater volcano introduces diversity, allowing pockets of life to flourish around chemical gradients. Here, life persists in subtle, patient forms, quietly thriving without the drama of sunlight, tides, or waves. Creatures of the abyssal plains have evolved remarkable adaptations. Many are transparent, conserving energy and avoiding predation. Others produce bioluminescence, emitting faint, ghostly light to attract mates, lure prey, or confuse predators. Some species can survive for years without food, slowing metabolism to a near standstill until the next marine snow shower arrives. The calm rhythm of existence in the abyss is a lesson in patience, adaptation, and subtlety. Life moving quietly in a vast, silent world. The abyssal plains also host hidden geological features that are invisible to casual observation. Tiny ridges, submerged volcanic formations, and underwater landslides punctuate the flatness, creating microhabitats that sustain biodiversity. Sediment cores taken from these areas reveal ancient climate records, chemical compositions, and the slow accumulation of life over millions of years. In essence, the plains are a library of Earth's deep history, quietly recording the passage of time beneath kilometers of water. Exploration of the abyssal plains is challenging but profoundly rewarding. Remotely operated vehicles, ROVs, glide across the seafloor, capturing high-resolution images of life and terrain. Sediment traps and deep-sea landers collect samples for analysis, revealing previously unknown species and chemical processes. Even in these calm, flat regions, surprises await. An unusual fish, a bioluminescent bloom, or a vent of cold methane can create temporary bursts of activity in an otherwise steady world. Human presence on the abyssal plains is fleeting. Only a handful of locations have been directly observed, and most of the plains remain entirely untouched. This remoteness has preserved delicate ecosystems where evolution proceeds at its own slow, deliberate pace. In the absence of sunlight, predators and prey interact in near silence. Movements are cautious, and the entire ecosystem operates with quiet efficiency. Interestingly, the abyssal plains are also linked to global processes. Ocean currents transport nutrients and heat across vast distances, influencing life not only in the plains, but also in shallower waters and even surface ecosystems. The plains act as a sink for carbon and minerals, absorbing organic material from above and storing it for centuries. In this sense, the deep, calm floor of the ocean contributes to Earth's overall climate stability, quietly regulating processes that affect life on the surface. For humans, contemplating the abyssal plains inspires both humility and awe. Here is a world larger than any city, deeper than any mountain is high, and largely unknown despite centuries of ocean study. The calm, patient movements of life on the plains reflect a rhythm entirely independent of human time, a reminder that the planet has its own cycles, flowing quietly in the deep, unseen regions of the world. In essence, the abyssal plains are a paradox, flat, featureless, and alien to human eyes, yet teeming with life and history. They are silent, yet dynamic, still, yet profoundly alive. To imagine drifting across these plains is to enter a world of quiet patience, subtle beauty, and enduring resilience, a realm where the ocean's deepest secrets continue to unfold, untouched and unseen by humanity. Section 3. Hydrothermal Vents. Alien oases in the dark. Deep beneath the ocean's surface, far beyond the reach of sunlight, exist extraordinary oases of life, hydrothermal vents. These volcanic chimneys, often called black smokers or white smokers, depending on the minerals they emit, spew superheated water rich in dissolved chemicals from beneath the Earth's crust. In the surrounding darkness, these vents create ecosystems unlike any other on the planet, entirely independent of photosynthesis, where life thrives through chemical energy alone. Hydrothermal vents form along mid-ocean ridges and tectonic boundaries, where magma heats seawater that seeps through fissures in the ocean floor. The water emerges at temperatures exceeding 400 degrees Celsius, 752 degrees Fahrenheit, laden with sulfides, iron, and other minerals. When this scalding fluid mixes with the near-freezing seawater of the deep ocean, dramatic plumes of mineral-laden smoke rise, providing both structure and nourishment to a myriad of specialized organisms. The vents themselves resemble alien skyscrapers, their chimneys twisting and spiraling in the dark waters, towering meters above the seafloor. Life at hydrothermal vents is astonishing in both form and function. At the base of the ecosystem are chemosynthetic bacteria, which convert the vent's minerals into energy, forming the foundation of an intricate food web. These bacteria live symbiotically inside larger organisms, such as giant tube worms, which can reach over 2 meters in length. The worm's bright red plumes absorb hydrogen sulfide from vent fluids, sustaining the bacteria within their bodies. Clams, mussels, and shrimp cluster near the vents, each uniquely adapted to withstand intense heat, high pressure, and toxic chemicals, yet thriving in this otherwise hostile environment. Hydrothermal vent ecosystems are astonishingly dense and active, given their extreme conditions. Unlike the sparsely populated abyssal plains, vents are bustling hubs of life, where organisms gather in close quarters to extract energy from chemical gradients. Predators patrol the edges, while scavengers navigate crevices and chimneys. Despite the absence of sunlight, the vents are alive with motion and subtle glow. Bioluminescent organisms flicker. Small shrimp pulse in coordinated movements, and the faint warmth radiates through the surrounding water, creating an eerie, almost magical atmosphere. The chemistry of the vent fluids also gives rise to unique adaptations. Some species tolerate extreme acidity, others withstand high concentrations of heavy metals. Giant worms possess no digestive system, relying entirely on their internal bacterial symbionts for nourishment. Shrimp use specialized hairs to detect chemical cues in the water, guiding them to food sources, mates, or shelter. This world demonstrates life's incredible capacity to adapt, thriving under conditions that would be fatal to surface organisms. Hydrothermal vents are also dynamic and transient. New vents can form suddenly when tectonic activity fractures the crust, while old vents may cool or collapse over decades. The organisms inhabiting them must respond, either migrating to newly formed vents or adapting to diminished chemical flows. In this sense, vents are not static oases, but living laboratories, where evolution and survival are ongoing processes in a harsh, shifting environment. Beyond biological fascination, hydrothermal vents play a critical role in global chemical cycles. They release minerals and trace elements into the ocean, influencing water chemistry and nutrient availability. The vent bacteria and associated ecosystems also contribute to carbon cycling, processing organic matter and altering chemical balance in the deep sea. In essence, these remote structures quietly sustain life and influence planetary processes, despite existing in some of the most extreme and inaccessible places on Earth. Exploration of hydrothermal vents remains challenging but rewarding. Manned submersibles and remotely operated vehicles descend into crushing depths, maneuvering near vent chimneys to observe organisms, capture video footage, and collect samples of water, rock, and microbial life. The discoveries have been astonishing. New species with transparent bodies, glowing appendages, and previously unknown metabolic pathways. Each dive reveals the resilience and ingenuity of life, reminding us that Earth's most remote regions still harbor secrets that defy imagination. Hydrothermal vents also inspire reflection on the origin of life. Some scientists speculate that similar environments may have been the cradle for early life on Earth, providing heat, chemical gradients, and protection from harsh surface conditions. By studying vents, we glimpse processes that may have shaped life itself, deepening our understanding of biology, evolution, and the potential for life beyond Earth. The deep ocean, with its hydrothermal vents, offers a profound sense of calm and wonder. Here, life persists without sunlight, in perpetual darkness and extreme pressure, demonstrating the resilience, adaptability, and quiet determination of living systems. Observing these alien ecosystems is like peering into another world, one where the ordinary rules of surface life do not apply. Yet complexity, beauty, and rhythm persist. In the grand tapestry of the ocean, hydrothermal vents are glowing points of life, mysterious and serene, reminding us that Earth's secrets are not only vast in scale, but astonishing in their ingenuity. They are places no human has fully seen, yet their silent activity continues undisturbed, a meditation on persistence, adaptation, and the deep, enduring pulse of our planet's hidden oceans. Section 4. Underwater Caves and Submerged Rivers. Labyrinths in the deep, beneath the calm surface of our oceans, lies a hidden world of winding passages, vaulted chambers, and ancient corridors, a labyrinth sculpted by time and water. These underwater caves and submerged rivers are among the most mysterious and beautiful environments on Earth, places where the boundary between land and sea seems to blur into dreamlike silence. They are not just geological features, but repositories of history, biology, and evolution, holding stories of a planet forever reshaped by water. Most of these caves were once dry. During the last ice age, when sea levels were lower, rainwater seeped into limestone, slowly dissolving it over millennia to create vast networks of caverns. As the ice melted and the oceans rose, the entrances flooded, sealing within them entire worlds, fossils, prehistoric air pockets, and even ancient tools left behind by early humans. To dive into one of these caves today is to slip into the memory of the Earth itself. The cenotes of the Yucatan Peninsula in Mexico are among the most famous of these submerged worlds. To the ancient Maya, they were sacred portals to the underworld, gateways where the living could commune with spirits. Today, they appear as deep blue pools surrounded by jungle, their surfaces calm and reflective. But beneath them opens a realm of astonishing complexity. Divers pass through shafts of shimmering light into caverns filled with stalactites and stalagmites, their forms preserved beneath the water for thousands of years. Some cenotes connect to immense subterranean river systems like Sac Acton and Dos Ojos, which stretch for hundreds of kilometers, among the longest underwater cave systems known to science. The experience inside these caves is otherworldly. The water is often so clear that it appears invisible, giving divers the illusion of floating in air. Each movement stirs up the fine silt that has settled over centuries, creating ghostly clouds that hang in the stillness. Light from headlamps flickers off mineral formations that took eons to form, turning them into living sculptures. The silence is complete. No waves, no currents, only the soft rhythm of breathing and the distant echo of bubbles rising toward stone ceilings. It is an encounter with deep time, an immersion in serenity and solitude that few other places can offer. But these caves are not only beautiful, they are scientifically invaluable. They preserve some of the most detailed geological records of climate change, trapped in layers of calcite that form like tree rings. By analyzing these deposits, scientists can reconstruct ancient rainfall patterns and temperature shifts, offering clues about how Earth's climate evolved. Fossils of extinct animals, including giant ground sloths and saber-toothed cats, have been found within their depths, perfectly preserved by the cold, still water. Some caves even contain the skeletal remains of early humans, giving anthropologists glimpses into migrations and rituals from tens of thousands of years ago. Elsewhere in the world, other forms of underwater labyrinths reveal different secrets. In the Bahamas, blue holes, deep circular sinkholes, drop vertically through layers of ancient limestone, forming portals into pitch-black depths. The water inside is often stratified, with a layer of fresh water floating above denser salt water, creating sharp visual distortions known as haloclines. Passing through one feels like crossing into another world. Colors shift, light bends, and even sound behaves differently. These blue holes have yielded astonishing discoveries. Previously unknown microbial life forms, perfectly preserved fossils, and chemical conditions that mimic what scientists believe early Earth's oceans may have been like. In Europe, underwater cave systems such as the Fontaine de Vaucluse in France and the Harani Abyss in the Czech Republic, the world's deepest known underwater cave, plunging beyond 450 meters, continue to challenge explorers. Despite decades of diving, many of these networks remain unmapped, their full extent hidden in darkness. The deeper divers go, the more alien the environment becomes. Visibility fades, temperatures drop, and the water grows heavy and silent. It is a place of beauty, but also of immense danger, demanding precision, calm, and respect from those who enter. Submerged rivers add another layer of mystery. In certain regions, particularly where freshwater springs flow beneath the ocean floor, true underwater rivers exist. These currents, heavier with minerals or salinity, snake along the seafloor like liquid shadows, complete with banks, rapids, and even waterfalls. One of the most spectacular examples is found in the Cenote Angelita in Mexico, where a dense layer of hydrogen sulfide creates the illusion of a flowing river 30 meters below the surface. Divers who descend into this submerged stream describe it as surreal. Trees and branches rise from the bottom, cloaked in mist, while the water above glows faintly with diffused light. It feels like stepping into a dream of the underworld. These submerged labyrinths also remind us how profoundly interconnected Earth's systems are. The same processes that carved caves on land now shape the ocean floor. Groundwater flow, mineral deposition, tectonic shifts all continue beneath the surface, unseen but ongoing. The beauty of underwater caves lies not just in their forms, but in what they represent. The slow, patient artistry of nature, sculpting wonder from stone and silence. And yet, these environments are delicate. Many cave systems are being affected by pollution, rising sea levels, and changing groundwater chemistry. What has survived for tens of thousands of years can be damaged in a single generation. Preserving them is not just about conserving beauty. It is about protecting the geological and biological archives that lie within them, the records of who we were and what the Earth once was. To drift through an underwater cave is to witness both the fragility and the endurance of nature. Every stalactite, every shimmering reflection, every echoing chamber whispers of time far beyond human comprehension. These submerged labyrinths are sanctuaries of silence, of stillness, of memory. The ocean's hidden temples, where the planet's past rests quietly, waiting to be rediscovered. Section 5. Creatures of the Abyss. Life at the deepest depths. Far below the waves, beyond the reach of sunlight, lies a world where darkness reigns eternal. Pressures here are immense, thousands of times greater than at the surface, and temperatures hover just above freezing. To human eyes, it may seem lifeless, but this realm, known as the Abyss, is alive with beings so strange, so perfectly adapted to the deep, that they defy imagination. They are the creatures of the Abyss, inhabitants of a world that has never known the warmth of the sun, yet thrives in the silence of perpetual night. As you descend past the twilight zone, the region where faint traces of sunlight still shimmer, the water grows colder, heavier, and darker. At depths of 1,000 meters, light from above has vanished completely. Here, in the abyssal plains and deep trenches, life survives through other sources of energy, often derived from the planet's own heat. What unfolds is not a dead wasteland, but an astonishing ecosystem sculpted by pressure, chemistry, and time. One of the first inhabitants encountered in this realm is the anglerfish, a symbol of the deep's eerie beauty. Its most distinctive feature, a glowing lure that extends from its forehead, is actually a beacon of bacteria that produce light through bioluminescence. In the absolute darkness, this small light becomes irresistible to smaller fish who approach thinking it is prey, only to be swallowed in a single gulp. The anglerfish's mouth is a wide, crescent trap lined with translucent teeth, designed to consume prey nearly its own size. And yet, despite its monstrous appearance, it moves with quiet grace, its body drifting weightlessly in the black water, its light flickering like a tiny star. Deeper still, around hydrothermal vents, another form of life emerges. One not powered by sunlight, but by chemosynthesis. These vents, found along tectonic ridges, spew scalding water rich in minerals and chemicals. It is here that entire colonies of giant tube worms, vent crabs, and blind shrimp thrive. The tube worms, which can grow over 2 meters long, have no mouths or stomachs. Instead, they host bacteria within their bodies that convert hydrogen sulfide into organic energy. In these lightless depths where most creatures might perish, life has found a way to create its own food, its own ecosystem, a miracle of biological ingenuity born in the furnace of the earth. Moving across the abyssal plains, vast, silty expanses that stretch for thousands of kilometers, one might find the sea cucumber. It glides slowly across the seafloor, sifting through sediments for microscopic nutrients. While unassuming in appearance, sea cucumbers are vital to the deep ocean's health, recycling organic matter and oxygenating the sediment. In some parts of the ocean, they are so abundant that they carpet the seafloor, creating what looks like a soft, undulating landscape of living motion. But not all creatures here are gentle. In the Hadal Zone, the deepest of all, plunging into trenches like the Mariana Trench, nearly 11 kilometers below the surface, Predators have evolved forms that seem almost alien. The deep-sea dragonfish, for example, glows with blue and red bioluminescent organs, colors invisible to most other creatures, but perfectly attuned to its own eyes. It uses this invisible light to hunt undetected, a stealth predator in the dark. Others, like the gulper eel, have evolved enormous expandable mouths to trap any prey they encounter. For food is scarce and unpredictable in this world. Perhaps the most astonishing creature of the abyss, however, is one of its smallest, the copepod, a tiny crustacean no larger than a grain of rice. It might seem insignificant, but it is among the most numerous organisms on the planet, forming the foundation of the oceanic food web. Even here, in the cold, crushing dark, copepods shimmer faintly with bioluminescent pulses, turning the deep into a flickering constellation of microscopic life. Bioluminescence, in fact, defines much of the abyss. Without sunlight, light becomes a language, a tool for hunting, camouflage, communication, even love. Some squid produce sudden flashes to startle predators. Others release glowing ink to distract and escape. Jellyfish drift by like drifting galaxies, their bodies trailing ribbons of light. In the deep, every spark of illumination is precious, a signal in the void. And though these creatures may never see the sun, they have created their own constellations in its absence. Exploring these depths is no small feat. Human missions to the abyss are rare, dangerous, and brief. The Trieste, the first manned submersible to reach the Mariana Trench in 1960, spent only 20 minutes on the seafloor. Yet it revealed a landscape unlike anything known before, still, featureless, and strangely peaceful. More recent missions, like James Cameron's Deep-Sea Challenger or Victor Vescovo's submersible expeditions, have shown us that even in the deepest, darkest corners of Earth, life endures. Amphipods, ghostly snailfish, and translucent crustaceans drift silently through the trenches, thriving under conditions that would crush most life forms instantly. There is a quiet poetry in this resilience. The creatures of the abyss live without light, often without motion, and yet they are among the most successful survivors on Earth. Some species have changed little for millions of years, their designs perfected by evolution's patient hand. In their stillness, they remind us that survival is not always loud or visible. Sometimes it is a matter of adapting silently, beautifully, to the impossible. And so, in the dark heart of the ocean, life continues, glowing softly, breathing slowly, waiting endlessly. It is a world without day or night, without sound or storm, yet full of motion and meaning. The abyss may seem empty, but it is not void. It is a sanctuary of endurance, a realm where life whispers, rather than shouts, that it is here, and that it always will be. Section 6. The Abyssal Plains, the true floor of the ocean. Imagine standing on the true floor of our planet, not the mountains or forests of land, but the vast plains that lie beneath miles of ocean water. Far below the surface, deeper than sunlight can ever reach, the abyssal plains stretch endlessly in all directions. They are the Earth's final horizon, the largest and flattest regions on the planet, yet among the least explored. Here, time slows. The water is perfectly still. The world above is a distant memory, and only the patient rhythm of the deep remains. The abyssal plains begin where the continental slopes end, usually around 3,000 to 6,000 meters below the surface. At these depths, the pressure is immense, hundreds of times greater than the atmosphere at sea level. But the landscape is astonishingly gentle. Unlike the chaotic ridges and trenches of other oceanic zones, the abyssal plains are remarkably smooth, covered in a fine blanket of sediment that has settled over millions of years. This sediment is made from the slow rain of particles drifting down from the upper ocean. Dust, minerals, dead plankton, and microscopic shells. Each grain tells a story of ancient eruptions, of passing currents, of life that once floated above. It is hard to imagine a place so vast and yet so quiet. If you could look out across an abyssal plain, the view would resemble a desert of darkness. The floor is featureless, except for the occasional ripple of sand, a scattered rock, or the faint imprint of a creature that once passed by. The silence is absolute, broken only by the slow movement of deep-sea currents, ghost-like rivers of water that flow sluggishly through the dark, shaping the seafloor in subtle, unseen ways. Yet, even in this apparent emptiness, life persists. The abyssal plains are home to a delicate ecosystem, built upon scarcity and patience. Sea cucumbers drift slowly across the sediment, leaving looping trails behind them. Brittle stars stretch out their long arms to capture drifting detritus, while polychaete worms tunnel through the mud, recycling nutrients that sustain the entire community. The creatures here are slow, quiet, and astonishingly efficient, every movement conserved, every meal stretched across days or weeks. One of the most haunting sights of the abyssal plains is the presence of marine snow, a continuous fall of organic material from the surface world above. To the creatures below, it is both sustenance and connection. Each flake is a fragment of life that once basked in sunlight. The remains of plankton, the dust of storms, the ashes of volcanic eruptions. Over time, this gentle snowfall becomes the seafloor itself, compressing into layers that record the passing of ages. In this way, the abyssal plains are not dead. They are archives of time, preserving every breath and heartbeat that ever touched the ocean. There are also moments of quiet wonder, brief interruptions in the monotony that reveal the hidden vitality of this world. Deep-sea octopuses guard their eggs for years, wrapped around rocky outcrops that rise from the plains. Giant isopods resembling enormous pillbugs roam the sediments in slow, deliberate motions. Sometimes, an enormous whale fall, the carcass of a whale that has sunk from above, lands upon the seafloor, transforming the area into a temporary oasis of abundance. Hundreds of species gather to feed, each one adapted to take advantage of this rare feast. Within months, only bones remain, which in turn become habitats for bacteria and worms that feed on the fats within the skeleton itself. Nothing is wasted here. Even in death, life continues to nourish life. The geological structure of these plains tells another story, one of the Earth's deep, restless nature. Beneath the soft sediments lies the basaltic crust of the ocean floor, born from volcanic eruptions at mid-ocean ridges. Over millions of years, as tectonic plates move, this crust cools and sinks, flattening into the wide plains we see today. In some places, hydrothermal vents still push through the sediment, releasing warm, mineral-rich water that sustains isolated communities of life. In others, manganese nodules, round metallic stones that grow atom by atom over millions of years, litter the seafloor, silent reminders of Earth's slow chemistry at work. Exploration of these regions has been extremely limited. The darkness, depth, and crushing pressure make it one of the most inaccessible environments on Earth. Most of what we know comes from robotic submersibles, sonar mapping, and the rare footage captured by deep-diving vehicles. Even so, vast portions of the abyssal plains remain unmapped. It is possible, even likely, that entire ecosystems, and perhaps unknown species, lie undiscovered in these silent depths. When we peer into these landscapes, there is something almost meditative about their stillness. Unlike the bustling life of coral reefs or the turbulence of shallow seas, the abyssal plains move at a different rhythm, one measured in centuries, not moments. Sediment accumulates at the pace of millimeters per millennium. Creatures drift through lifetimes without ever encountering another of their kind. It is an existence defined by slowness, patience, and quiet resilience. But as peaceful as they seem, these plains are not immune to change. Human activity, even from far above, is beginning to touch the deep. Microplastics have been found embedded in abyssal sediments. Proposals for deep-sea mining threaten to disturb regions that have remained untouched for eons. Each disturbance, each vibration, could erase the delicate balance that life here has maintained since the dawn of time. To imagine standing on the abyssal plain is to feel both awe and humility. There are no stars, no sound, no motion, only the weight of the ocean pressing from above and the faint shimmer of life that persists against all odds. The creatures that inhabit these plains do not see light, yet they endure. They remind us that survival can take many forms, sometimes fierce and radiant, sometimes slow and invisible. In the endless stillness of the abyssal plains, there is a strange kind of peace. It is the peace of time stretched thin, of a world that has learned to exist without haste. Down here, the earth is not silent. It is simply listening. Section 7. Volcanic fire beneath the waves. The birth of new oceans. Beneath the calm surface of the seas lies one of the most extraordinary contradictions in all of nature. A world of fire within water. At the deepest parts of the ocean floor, along vast ridges that circle the planet like seams on a baseball, the Earth is continually being reborn. Here, volcanic fire breathes through mid-ocean ridges, hydrothermal vents, and underwater volcanoes, forging new crust, reshaping continents, and giving rise to ecosystems unlike any other on Earth. It is in these hidden forges that the planet renews itself, quietly, constantly, and beautifully. The story begins along the mid-Atlantic ridge, the longest mountain range on Earth, stretching more than 65,000 kilometers beneath the sea. Here, tectonic plates are slowly pulling apart, a process known as seafloor spreading. Magma rises from deep within the mantle to fill the gap, hardening as it cools, creating brand new oceanic crust. Though the process is invisible to human eyes, it happens on an epic scale. Every year, the Atlantic Ocean grows wider by about 2 centimeters. In the vast timeline of Earth, that is an unending breath, slow, patient, but unstoppable. To imagine this hidden world, picture towering volcanic ridges rising thousands of meters from the seafloor, their peaks cloaked in darkness. Between them lie valleys lined with fissures and vents, where superheated water, reaching temperatures over 400 degrees Celsius, bursts into the freezing ocean. These are the black smokers and white smokers, hydrothermal chimneys that spew mineral-rich plumes into the abyss. As the hot water meets the cold sea, minerals like iron, copper, and zinc precipitate, forming pillars that grow taller over time, sometimes reaching heights of more than 20 meters. They look like chimneys of another world, glowing faintly with the heat of creation. Yet even in this seemingly hostile environment, life flourishes. Surrounding the vents are communities of creatures found nowhere else on Earth. Giant tube worms, vent crabs, blind shrimp, and Pompeii worms, each adapted to survive in the heat and toxicity. Instead of drawing energy from sunlight, these organisms rely on chemosynthesis, a process in which bacteria convert hydrogen sulfide, the very gas that would kill most surface life, into nourishment. It is a reminder that life is not bound to the sun, but to energy itself, wherever it can be found. The sight of these ecosystems is breathtaking. Shimmering plumes rise like smoke into the darkness, illuminated by the faint glow of bioluminescent creatures. Bacteria form colorful mats that ripple in the currents, painting the rocks in shades of gold and silver. Tube worms stand upright in dense colonies, their white bodies capped with bright red plumes that sway like coral in an unseen tide. Every inch of this environment seems alive, a living city powered not by light, but by chemistry. The temperature here can change in the span of a meter, from freezing cold to boiling heat, yet organisms have evolved to survive both extremes. The Pompeii worm, one of the most heat-tolerant animals known, lives directly on the vent walls, enduring temperatures above 80 degrees Celsius. Its body is protected by a layer of symbiotic bacteria that insulate it from the heat, forming one of nature's most remarkable partnerships. Life here is not just surviving, it is thriving, adapting to conditions that would be unthinkable anywhere else. But volcanic activity under the sea is not limited to vents. Entire submarine volcanoes exist, rising thousands of meters from the abyssal plains. Some are active, others dormant, their peaks hidden far below the waves. Occasionally, one erupts with enough force to break the surface, forming new islands. The islands of Iceland, Hawaii, and many in the Pacific were born this way, forged in fire beneath the water, before emerging into light. Each eruption is a moment of transformation, where the deep ocean gives birth to new land, where continents begin their stories. The connection between these volcanic forges and the living world is profound. The minerals released from vents and eruptions feed deep ocean currents, which in turn nourish the upper layers of the sea. Iron from these sources helps fuel plankton blooms that sustain entire food webs. Even the heat itself drives circulation patterns that influence global climate. In this way, the silent activity of the deep, invisible and ancient, sustains the surface world in ways we are only beginning to understand. Over geological time, the shifting and spreading of these oceanic ridges have sculpted the planet itself. Continents drift, collide, and split apart under their influence. The Atlantic Ocean exists because of them. So does the Pacific's ring of fire. The deep earth and the shallow seas are one continuous system, breathing together, expanding and contracting through cycles of unimaginable length. When we study these volcanic regions, we glimpse not only our planet's past, but also its future. The conditions around hydrothermal vents may resemble those that existed billions of years ago, when life first arose. The discovery of chemosynthetic bacteria has led scientists to propose that the earliest forms of life could have begun in similar environments, in the warmth of volcanic vents, protected from the harsh radiation of the young sun. In other words, the origins of all life may lie not in sunlight, but in the fire and minerals of the deep sea. Today, we continue to explore these regions with robotic submersibles and autonomous vehicles. The images they return are both strange and serene. Towering mineral spires, glowing in the darkness, delicate life forms drifting in the plumes, the faint rumble of the earth beneath. It is easy to forget that this ceaseless geological activity, happening miles below the surface, is part of the same planet that grows forests, rivers, and cities. There is something deeply comforting about this cycle of renewal. The earth is not static. It is alive, moving, changing, evolving, in the most remote corners of the ocean. Beneath the crushing pressure, beneath the silence, beneath the endless weight of the sea, the planet is still creating. The fire never went out. It merely moved below the surface, where it continues to forge the foundations of our world. And so, in the heart of the ocean's darkness, where light never reaches and time feels endless, there is the quiet pulse of creation, a reminder that even in the coldest, deepest places, the earth still breathes. Section 8. The Midnight Zone, where darkness becomes a world. There is a place in the ocean where light surrenders completely, a region so dark that no sunlight, not even the faintest trace of blue, can reach. It begins roughly 1,000 meters beneath the surface and extends down to about 4,000. This is the Midnight Zone, or the bathypelagic realm, a world of perpetual night, immense pressure, and quiet mystery. Here, the sea becomes a black expanse, stretching in every direction. Temperatures hover just above freezing. The weight of the water above presses down with hundreds of atmospheres of force. To human senses, it would feel like the end of the world, cold, silent, and infinite. Yet for the creatures that call it home, it is simply where life continues, differently but beautifully. The first thing that defines this world is its darkness. Not merely the absence of light, but a presence all its own. In the midnight zone, darkness becomes texture, space, and rhythm. Movements are slow, deliberate, and purposeful. Sounds travel farther here than anywhere else on Earth, allowing whales to communicate across hundreds of kilometers. In this stillness, the ocean hums softly, a soundscape of life hidden in shadow. And yet, even here, light exists, not from the sun, but from the living. Bioluminescence is the heartbeat of the midnight zone. It is a quiet miracle repeated billions of times each night. Tiny plankton release sparks when disturbed, as if stars were born in the water. Larger animals, fish, jellyfish, shrimp, squid, create their own light through chemical reactions inside special organs called photophores. Some use their glow to hunt. The anglerfish, for instance, dangles a luminous lure in front of its mouth, attracting unsuspecting prey in the blackness. Others use it to hide. The hatchetfish, with its shimmering belly, emits just enough light to match the faint glow from above. A perfect camouflage known as counter-illumination. Still others use it to communicate or confuse. Sudden flashes to startle predators, or gentle pulses to attract mates. When explorers send submersibles into these depths, their lights illuminate surreal scenes. Transparent jellyfish drifting like ghosts, spiral-shaped siphonophores stretching longer than whales, and fish with translucent skin through which their glowing organs shimmer faintly. Each organism is a reflection of evolution's creativity, shaped by millions of years of adaptation to a world without sunlight. One of the most haunting residents of this realm is the barrel-eye fish, whose head is transparent. Inside its dome-like skull, two green, upward-pointing eyes gaze through the clear tissue, capturing the faintest bioluminescent glimmers above. When the fish spots prey, it can rotate those eyes forward, an eerie yet elegant solution for survival in eternal night. Then there is the giant squid, elusive and magnificent, drifting silently through the deep. For centuries, it was known only through legends and the occasional carcass washed ashore. Today, we know it as one of the ocean's largest and most mysterious predators, with eyes the size of dinner plates, the largest in the animal kingdom. Its enormous pupils gather every possible photon of light, detecting faint flashes that may reveal the movements of prey or the approach of a rival. The midnight zone is not merely a place of fear or strangeness. It is a place of balance, an ecosystem built on patience and precision. Food is scarce here. Most creatures rely on what scientists call marine snow, a slow, continuous drift of organic material from above. Dead plankton, fish scales, tiny particles of detritus. Over time, these delicate flakes accumulate on the seafloor, feeding life in the depths. Sometimes larger blessings fall. The carcass of a whale, for instance. When it descends from the surface, it becomes an entire ecosystem in itself. Over years, hundreds of species feed on it in succession, from scavenging sharks and hagfish to microscopic bacteria that consume what remains of the bones. A single whale fall can sustain a community for decades. In the stillness of the deep, even death becomes a source of life. And though humans have only just begun to explore it, the midnight zone plays a crucial role in the planet's balance. It is part of the Great Carbon Cycle, a vast mechanism through which the ocean stores carbon dioxide, regulating Earth's climate. Every time organic matter sinks, it carries with it carbon that might otherwise remain in the atmosphere. The dark ocean, in this way, acts as the planet's great lung, absorbing, storing, and breathing over centuries. Exploration here is still new, still humbling. Even today, with all our technology, we have seen only fragments of this world. Robotic submersibles descend into its depths for hours, sometimes days, capturing glimpses of creatures that vanish the moment light touches them. Cameras reveal colors our eyes can barely comprehend. Deep reds, faint greens, shimmering blues that fade as quickly as they appear. Each expedition is like exploring another planet, and in many ways it is. The conditions here, cold, high pressure, total darkness, are similar to what we might find on the icy moons of Jupiter and Saturn. Scientists studying life in the midnight zone often say that if life can exist here, it might also thrive elsewhere in the universe, under the frozen crusts of Europa or Enceladus, where liquid oceans may lie hidden below the ice. The midnight zone, then, is more than a layer of the ocean. It is a mirror of possibility, both for Earth and beyond, a reminder that life, once begun, finds a way to endure, even in the most unlikely places. To imagine yourself there, drifting silently in the dark, surrounded by glimmers of living light, is to feel both the immensity of the unknown and the serenity of existence. It is not a place of terror, but of wonder, a realm where the ocean dreams in silence, and where the boundary between life and mystery dissolves into one eternal night. In the stillness of the midnight zone, light becomes language and darkness becomes home. It is, in every sense, the ocean's most poetic secret. Section 9. The trenches into the heart of the earth. If the midnight zone is the ocean's eternal night, then the trenches are its cathedrals, immense, silent fissures that descend toward the very bones of the earth. These are the deepest places on the planet, where the seafloor folds and sinks back into the mantle, and where gravity itself seems to bend the shape of the world. The most famous of these, the Mariana Trench, lies in the western Pacific Ocean, east of the Philippines. It stretches nearly 2,550 kilometers long and plunges to an astonishing 10,984 meters at its deepest known point, Challenger Deep. To grasp that depth, imagine Mount Everest turned upside down and submerged. Its peak would still be more than 2 kilometers below the trench's rim. It is difficult to comprehend such a place. The pressure at the bottom of the Mariana Trench exceeds 1,100 times the air pressure at sea level, the equivalent of having nearly 8 tons pressing down on every square inch. Temperatures hover just above freezing. Sunlight never arrives. The water is still, dense, ancient, and yet somehow life persists. When early oceanographers first mapped these depths, they believed them to be lifeless, too extreme for biology. But as technology advanced, as robotic submersibles replaced lead weights and wire, the deep began to whisper its secrets. Each expedition revealed new species, new forms, new adaptations that seemed almost impossible. In 1960, the bathyscaphe Trieste, carrying Jacques Piccard and Dawn Walsh became the first human-occupied vessel to reach the Challenger Deep. Their descent took nearly 5 hours. Through the thick glass porthole, they reported a cloudy seabed, fine and pale, stirred by something alive. "We saw a flatfish," Picard noted later, "alive and well at the bottom of the world." In the decades that followed, robotic explorers confirmed what those first eyes glimpsed, that even under crushing pressure, life endures. In the sediment and water of the trench, scientists have found microbes that feed on hydrogen and methane, amphipods the size of hands, transparent sea cucumbers, and strange snailfish, pale, boneless creatures that ripple like silk in the currentless dark. The Mariana snailfish has become something of a symbol for deep-sea life. At depths over 8,000 meters, it thrives where few others can. Its body is gelatinous, flexible, not crushed, but adapted to pressure. Its cell membranes contain special molecules that prevent collapse, while its enzymes are uniquely stable. It is a living example of nature's quiet resilience, proof that life, given even the smallest chance, will find a way to bloom in silence. The trenches are more than geological scars. They are windows into the planet's interior, the places where one tectonic plate slides beneath another, in a process known as subduction. As the heavier plate descends, it drags water and sediment down with it, recycling them into the mantle. Over millions of years, that material melts and rises again, feeding volcanic arcs and shaping continents. In this way, the trenches are both the ocean's end and its beginning, the deep breath the Earth takes before exhaling mountains and islands into existence. Without them, the planet would grow stagnant, its crust unmoving, its surface unrenewed. Scientists studying the chemistry of trench sediments have also discovered something remarkable. These regions play a role in the long-term carbon cycle, helping to regulate the planet's atmosphere over geological time. Tiny fragments of dead organisms, buried under immense pressure, are subducted along with the seafloor, locking carbon deep within the planet. The deep ocean, it seems, is not only a graveyard, but a guardian, quietly preserving balance through eons. Exploring these depths, however, remains one of the greatest challenges in science. The pressure alone makes it nearly impossible. Most materials would collapse, electronics would fail, and even cables must be designed to resist the immense forces of the deep. Modern submersibles, such as DSV limiting factor, are engineering marvels, titanium spheres capable of descending repeatedly into the deepest trenches. When explorer Victor Vescovo piloted the limiting factor to the bottom of the Mariana Trench in 2019, he discovered something both extraordinary and troubling. Alongside previously unknown species, he found plastic debris, a single-use bag, and candy wrappers lying among the silt of the deepest ocean on Earth. It was a sobering reminder that even the planet's most hidden corners are not beyond our reach or our impact. Still, there is beauty here, quiet, stoic beauty. Imagine the seafloor of the trench, smooth plains of pale sediment, interrupted by ridges and faults, shimmering under the faint glow of bioluminescent creatures. The stillness is total. Every movement is slow, deliberate, shaped by the immense weight above. The water here has remained unchanged for centuries. Cold, oxygen-poor, undisturbed by surface storms. For scientists, each descent is not merely exploration, but meditation, a journey into time itself. The particles that drift here may have begun their fall decades or even centuries ago. A single grain of planktonic dust might take 1,000 years to settle on the trench floor. Everything here moves at the pace of eternity, and so, these trenches are not just deep, they are ancient. They record the planet's history in silence, layer upon layer, like pages in a book no one has yet learned to read fully. They remind us that Earth is not static, but alive, breathing, shifting, remaking itself endlessly. To stand, or rather to float, within one of these abysses would be to feel the planet's pulse, to see nothing but blackness, and yet know that all around you, invisible to the eye, life stirs quietly. The same laws that forged mountains and continents continue their patient work in this darkness, sculpting the world we live on. In the end, the trenches are not only the ocean's deepest places, they are its heart. A heart that beats slowly, imperceptibly, in rhythms measured not in seconds, but in millennia. A heart that swallows and renews, destroys and creates. If the ocean is the body of the earth, the trenches are its silent veins, carrying away what is old, so that something new can one day rise. And in that still, unseen world, life whispers its quiet truth, that even in the deepest darkness, the story of creation continues. Section 10. Alien Worlds Beneath the Sea, Life Without Sunlight. There are places in the ocean where the very foundation of life is rewritten, where heat replaces light, and chemistry becomes the language of existence. These are the hydrothermal vents, deep beneath the surface, found mostly along the mid-ocean ridges, the vast underwater mountain chains that encircle the earth like a scar. To reach them is to enter a world that seems alien in every sense. The seafloor here is torn open by tectonic forces. Magma rises from the mantle, heating the surrounding seawater to extraordinary temperatures. When this superheated water escapes through cracks in the crust, it emerges in towering plumes, clouds of darkness known as black smokers. These vents spew out mineral-rich water at temperatures exceeding 400 degrees Celsius, 750 Fahrenheit, though the surrounding ocean remains near freezing. The two extremes exist only centimeters apart. Iron, sulfur, and other elements pour into the water, where they instantly precipitate and solidify, forming black, chimney-like structures that grow taller with every pulse of venting fluid. If you could stand before one of these vents, inside a submersible, your lights illuminating the otherworldly landscape, it would look like an undersea volcano turned inside out. Clouds of mineral dust shimmer like smoke. The chimneys glow faintly from within. Strange creatures, pale and ghost-like, cluster around the vents, drawn to the heat and the invisible energy they provide. For most of Earth's history, scientists believed all life ultimately depended on sunlight. Plants and plankton captured energy from the sun through photosynthesis, creating the foundation for every food chain. But in 1977, during an expedition aboard the research vessel Alvin, scientists discovered the first hydrothermal vent ecosystem, and with it, an entirely new form of life's resilience. Around those vents, they found creatures thriving in utter darkness. Giant tube worms taller than a human, blind shrimp that sense heat instead of light, and crabs with bodies armored in minerals. None of these relied on sunlight. Instead, they drew energy from the earth itself, from chemicals seeping out of the vents. The key was a process known as chemosynthesis. Just as plants use sunlight to turn carbon dioxide and water into food, certain bacteria in these deep ecosystems use chemicals like hydrogen sulfide, the same gas that gives rotten eggs their smell, to produce energy. These microbes form the true base of life in the deep sea, turning poisonous compounds into nourishment. In the case of the giant tube worms, this relationship becomes intimate and complete. The worms have no mouth, no stomach, and no digestive system at all. Instead, their bodies are filled with chemosynthetic bacteria. The worms provide a home and the chemicals. The bacteria, in turn, provide food. It is one of the most perfect partnerships in nature, a living symbol of cooperation where survival depends entirely on trust. The landscape around hydrothermal vents is dynamic and fragile. Entire cities of life cluster around a single chimney, flourishing as long as the vent remains active. But when the heat source shifts, as it often does, the vents cool and the ecosystems fade away. Over time, new vents open elsewhere and life migrates again. It is a cycle of creation and renewal, echoing the rhythms of the planet itself. Some vents, however, glow not with black smoke, but with pale, ghostly plumes. These are the white smokers, where the water is cooler and the minerals differ, rich in barium, calcium, and silica, rather than iron and sulfur. Together, they form a vast mosaic of chemical landscapes across the ocean floor, each sustaining unique forms of life. What makes these vents especially fascinating is their connection to the origins of life itself. Many scientists believe that life on Earth may have begun in places like these billions of years ago. The conditions, warm water, rich minerals, natural catalysts, and a continuous source of chemical energy, provide exactly the environment where organic molecules could assemble and evolve. In this view, the ocean's first cells may have formed not under sunlight, but in darkness, nurtured by the planet's internal heat. The vents, then, are not just ecosystems. They are time machines, showing us how life might have begun and how it could exist elsewhere in the cosmos. Indeed, when we imagine extraterrestrial life on icy moons like Europa or Enceladus, scientists often look to hydrothermal vents for inspiration. Beneath those frozen surfaces may lie oceans warmed from below by tidal forces and geological activity. If vents exist there, life might too, microbial perhaps, but alive nonetheless, feeding on the same chemistry that sustains Earth's deep-sea communities. To drift through this underworld in a submersible is to witness something both alien and deeply familiar. The flickering lights of the vents resemble campfires in the night, ancient, primal, comforting. The creatures that gather there seem improbable yet harmonious, moving slowly through clouds of mineral dust, their lives governed by unseen energy. It is also a place of paradoxes. The water that gushes from the vents is hot enough to melt lead, yet just beyond the plumes, the temperature drops to near freezing. The pressure could crush steel, and yet fragile creatures float effortlessly through it. No sunlight, no photosynthesis, and yet entire ecosystems thrive. The deeper one looks, the more the boundaries of what we call possible blur and expand. Over time, vents collapse, their chimneys crumble, and new ones form elsewhere. In this endless cycle of destruction and renewal, the deep ocean breathes. Each plume of heat rising from the seafloor carries with it a whisper of Earth's heartbeat, the rhythm of creation, still pulsing after billions of years. When the explorers turn off their submersible lights, something magical happens. The black smokers glow faintly in the distance, surrounded by the soft blue shimmer of bioluminescent plankton. It feels like drifting above a distant planet, surrounded by life that has never seen the sky, life that needs no stars to thrive. In that silence, the mind understands something simple and profound, that life, in its most essential form, does not depend on light or warmth or comfort, only on possibility. And beneath miles of ocean, in the deep furnace of the world, that possibility burns still, quietly, steadily, eternally. Section 11. Frozen Abysses. Life beneath the polar ice. At the farthest reaches of our planet, where the sun barely rises and the air itself bites like glass, the ocean continues, cold, still, and astonishingly alive. Beneath the polar ice caps, in the waters of the Arctic and Antarctic, lies a world that seems impossible. An underwater kingdom sealed beneath meters of ice, hidden from light for months or even centuries at a time. From above, these regions look lifeless, white expanses of ice and snow stretching to the horizon. Yet beneath that frozen surface, the ocean teems with life, so delicate and resilient it defies all logic. Here, in what may be the most inhospitable environment on Earth, evolution has written some of its most poetic stories. The journey into these frozen abysses begins with the ice itself. Sea ice is not a uniform block, but a living structure. It forms intricate networks of brine channels, tiny veins filled with super salty water. Within these narrow spaces, microscopic organisms find refuge. Diatoms, algae, and bacteria thrive in this frigid maze, forming the base of an entire hidden ecosystem. When sunlight filters weakly through the ice during the brief polar summer, it sparks a bloom of life. The algae multiply, coloring the underside of the ice in shades of green and brown. Tiny crustaceans, such as copepods and krill, gather to feed on this feast. From there, life expands outward and upward. Fish, seals, penguins, and whales, all part of a food chain rooted in the thin, icy film that floats between worlds. But as we descend deeper, the light fades again. The ocean beneath the ice becomes a cold twilight realm. The temperature hovers around -1.8 degrees Celsius, just above the freezing point of seawater. The pressure increases. The silence becomes absolute. And still, life persists. Some of the creatures found here are like living jewels sculpted by the cold. The icefish of Antarctica, for example, is one of the only vertebrates known to have no red blood cells. Its blood is almost transparent, allowing oxygen to dissolve directly into its plasma, a remarkable adaptation to frigid water that holds more dissolved oxygen than warmer seas. To survive where others would freeze solid, The ice fish produces special antifreeze proteins that keep its body fluids liquid even at sub-zero temperatures. The Antarctic krill, perhaps the most abundant animal on Earth by biomass, forms massive, glowing swarms beneath the ice, sometimes stretching for kilometers. They feed on the algae that cling to the underside of the ice, turning invisible light into living energy. Entire species, from penguins to blue whales, depend on their cyclical rise and fall through the water column. When krill migrate to deeper layers during the long winter darkness, they bring energy with them, feeding the deep ocean in ways scientists are only beginning to understand. Deeper still, near the continental shelves beneath Antarctica, explorers have discovered something even more extraordinary: hidden lakes and rivers sealed under ice for millions of years. One of the most famous, Lake Vostok, lies buried beneath nearly 4 kilometers of solid ice. Cut off from the surface since before humans existed, it contains unique chemical signatures and perhaps microbial life forms that have evolved in total isolation. When Russian scientists first drilled into Lake Vostok in 2012, the water samples they retrieved revealed DNA from dozens of previously unknown microorganisms. Some appeared similar to bacteria found near hydrothermal vents, hinting at a deep connection between these frozen abysses and the volcanic forces of the planet's interior. Others were completely new, life unlike any seen before. The idea that entire ecosystems might exist in total isolation, sealed away from the rest of the biosphere for millions of years, is both eerie and humbling. It suggests that life, once it begins, may not need constant sunlight or even surface contact to endure. It adapts, it transforms, it waits. The Arctic tells a similar story, though its waters are changing rapidly. As global temperatures rise, sea ice melts earlier and refreezes later each year, altering the delicate balance of these ecosystems. Some species, like polar cod and ice-dependent plankton, face uncertain futures. Others, more adaptable, move northward to fill the void. Yet even amid this transformation, the polar oceans continue to astonish. In 2019, researchers drilling through the ice shelf of the Ross Sea discovered a thriving community of amphipods, small, shrimp-like creatures, living 600 kilometers from open water, under nearly a kilometer of ice. Their presence raised a profound question. How did they survive so far from sunlight, so cut off from the rest of the sea? The answer, scientists believe, lies in unseen currents that flow beneath the ice, bringing nutrients from distant waters and sustaining pockets of life like hidden oases in the cold. These discoveries echo something ancient and cosmic. When scientists imagine life on distant icy moons like Europa or Enceladus, they often point to Earth's polar seas as their closest analog. Beneath those alien ice shells, warmed by tidal forces instead of sunlight, could exist oceans just like these, dark, cold, and filled with microbial life, clinging to chemical energy. In this way, the frozen abysses of Earth are not merely earthly at all. They are previews of other worlds, reminders that the story of life may be far broader and deeper than we can yet imagine. To imagine yourself there, floating beneath a ceiling of ice, in water so clear it feels like breathing in silence, is to feel the planet's ancient calm. The faint glow of bioluminescent plankton drifts past like stars. Somewhere in the dark, the song of a distant whale ripples through the cold. Above you, meters of ice shimmer faintly in the dim blue light of a world frozen in time. In these hidden oceans, the boundaries between stillness and life, between survival and beauty, dissolve completely. The polar seas are not barren. They are alive in slow motion, their rhythms measured not in days or seasons, but in centuries. And as we explore them, we are reminded of something profound, that even in silence, even in ice, the earth continues to dream. Section 12. The Sound of the Deep. How the Ocean Hears and Speaks. In the deep ocean, where light cannot reach and sight becomes useless, sound reigns supreme. It is the ocean's voice, its language, its heartbeat. Down here, in the world of eternal twilight and slow-moving life, communication and perception do not depend on light, but on vibration. The sea is not silent. It is a vast and living symphony, a world composed entirely of echoes. To us, the deep might seem quiet, an abyss of still water and distant shadows. But if one could listen closely, truly listen, the ocean would reveal its constant murmur. The slow rumble of underwater earthquakes, the far-off call of a whale, the crackle of shrimp colonies, the faint hum of water shifting through coral and sand. Every movement, every creature, every current produces sound. And because water is denser than air, these sounds travel extraordinarily far, sometimes across entire ocean basins. For marine life, this is not background noise. It is information. Whales navigate and find each other using low-frequency sounds that can travel thousands of kilometers. Dolphins create rapid, intricate clicks and whistles, each individual possessing a unique signature whistle, their name in sound. Even small fish and invertebrates use vibration to communicate, attract mates, or warn of danger. The ocean, in this way, is filled with countless voices layered upon one another, forming an invisible tapestry of meaning. The speed of sound in seawater is about 1,500 meters per second, nearly 5 times faster than in air. But it does not move the same way everywhere. Temperature, pressure, and salinity all influence how sound bends and travels. At certain depths, around 1,000 meters, these factors balance perfectly, creating a channel known as the SOFAR layer, short for sound fixing and ranging. Here, sound can travel for thousands of kilometers with almost no loss of energy. It's as if the ocean has built its own acoustic highway where sound waves can circle the globe. During the Cold War, scientists discovered this layer while developing sonar systems, but nature had known it for eons. Blue whales, the largest animals on Earth, may use it to communicate across entire oceans. Their calls, low, deep moans that can fall below the range of human hearing, can travel more than 5,000 kilometers. It is humbling to imagine two whales separated by continents, exchanging messages through the planet's watery depths, a dialogue of giants carried on invisible waves. Other species compose their own forms of oceanic music. The humpback whale is the poet of the sea. Each male sings long, haunting songs that can last for hours, weaving together patterns of notes that evolve over time. These songs drift through the water like ancient hymns, mysterious, structured, and endlessly beautiful. Scientists believe they play a role in courtship, but there is also evidence that humpbacks adjust and remix their songs, borrowing elements from other populations. In this way, whale songs form something like an ever-changing cultural conversation beneath the waves. Then there are the smaller, subtler voices. Coral reefs, though shallow compared to the abyss, are astonishingly loud environments. Thousands of creatures, snapping shrimp, croaking fish, crackling crustaceans, combine to produce a steady, crackling sound that scientists call the reef chorus. It is both chaotic and harmonious, a living pulse that changes with the tides and the time of day. To young fish drifting in from the open sea, the sound of a healthy reef acts as a beacon, a sign that home is near. Even the smallest creatures take part. Snapping shrimp, sometimes called pistol shrimp, create one of the loudest sounds in the ocean relative to their size. They snap their claws shut so fast that they generate a bubble that collapses with a shock wave, momentarily producing heat as hot as the sun's surface. The sound can stun prey and contribute to the crackling hum of shallow seas. But the deep ocean soundscape is different. Slower, lower, vast. It's filled with the groaning of tectonic plates, the long sigh of distant currents, and the haunting songs of baleen whales. The silence here is not empty. It is filled with slow vibrations, frequencies that seem more felt than heard. Human technology has recently made it possible to listen to this world. Networks of hydrophones, underwater microphones, record the ocean's sounds, allowing scientists to study everything from whale migrations to underwater volcanoes. Through them, we can hear the pulse of the planet itself. The low hum of the Earth, known as seismic noise, ripples constantly through the deep, a reminder that even when nothing seems to move, the world is never truly still. Some sounds are natural, but others are not. Over the past century, the ocean has grown louder, not through life, but through us. Ship engines, sonar systems, seismic surveys, and industrial activities have filled the water with artificial noise. These sounds can travel far and interfere with the communication of marine animals, confusing whales and driving them off ancient migratory paths. The ocean's conversation is becoming harder to hear. And yet, even amid this growing noise, the deep sea continues to sing. In 1997, researchers from NOAA detected a mysterious, low-frequency sound off the coast of South America. It was named the bloop. For years, it puzzled scientists, so powerful that it was heard by multiple sensors thousands of kilometers apart. Many wondered if it came from an unknown creature of immense size. But later studies revealed a simpler, yet equally awe-inspiring explanation. It was the sound of ice, a massive icequake from an Antarctic glacier, fracturing deep beneath the sea. Even the planet's frozen heart has a voice. There is something profoundly calming in this realization. That sound, invisible and fleeting, connects everything in the ocean. From the faint crack of melting ice to the song of a whale echoing through the dark, every vibration becomes part of a greater harmony. It is as if the ocean itself is a living instrument, tuned by gravity, temperature, and time. To drift through this world in silence, hearing only the echoes of unseen lives, is to feel the pulse of the planet in its purest form. The deep does not shout, it hums, it murmurs, it breathes. And if you listen long enough, you realize that the ocean isn't just full of sound, it is sound. A continuous, fluid song that began long before us and will continue long after we are gone. Section 13. The Abyssal Plains, Earth's greatest hidden landscapes. Far below the waves, deeper than any light can reach, lie the abyssal plains, vast, silent, and seemingly endless. These are the most extensive regions on Earth, covering more than half of the planet's surface, yet almost no one has ever seen them. To descend here is to enter another world, one of perpetual night, immense stillness, and ancient beauty. At first glance, the abyssal plains appear empty, smooth. Flat expanses stretch in every direction, broken only by the occasional seamount, volcanic ridge, or deep trench. The water pressure is crushing, thousands of times greater than at the surface, and the temperature hovers just above freezing. Sunlight is a memory, and time feels slower here, measured not in days, but in the slow fall of marine snow. That is what sustains life here, a gentle, continuous rain of organic particles drifting down from the upper ocean. Tiny bits of plankton, fragments of shells, microscopic remains, all descend through the darkness, taking weeks or even months to reach the bottom. When they arrive, they settle like dust on the seafloor, forming a layer of soft sediment that records the passing ages. Each grain is a memory of something that once lived in the light. Despite the harshness, life exists here, delicate, patient, and perfectly adapted. Sea cucumbers crawl slowly across the plains, feeding on the marine snow. Brittle stars stretch out their thin, luminous arms to catch falling particles. Small, translucent fish hover motionless, conserving every bit of energy. In this world of scarcity, efficiency is everything. To survive in the abyss, a creature must learn to do much with almost nothing. The abyssal plains may seem unchanging, but beneath their surface lies hidden drama. The seafloor here is not dead. It moves, breathes, and transforms, though at a pace almost too slow for human minds to grasp. Sediment accumulates over millions of years, burying the shells of ancient creatures, while tectonic plates drift and collide far below. Occasionally, an underwater landslide or volcanic eruption will disturb the calm, sending plumes of sediment billowing into the dark. Brief storms in an otherwise eternal stillness. There is also something strangely beautiful about the shapes that form here. The plains are often interrupted by abyssal hills, small undulations that rise a few hundred meters above the flat terrain. Over geological time, they are covered by sediment, giving the seafloor a soft, rippling texture, like the folds of a sleeping giant's blanket. And though light cannot penetrate these depths, there are still faint glimmers. Some organisms here are bioluminescent, glowing softly in the black water. A jellyfish pulses with ghostly blue light. A worm releases sparks as it moves through the sediment. Even bacteria on the seafloor may emit a faint glow, turning patches of mud into shimmering fields of living stars. In this way, the abyss becomes its own night sky. In recent years, explorers have begun to uncover more of these mysterious landscapes. Robotic submarines and deep-sea drones have mapped portions of the abyss with astonishing precision. What they found defied expectations. Ridges as tall as the Alps, hidden beneath miles of water, canyons wider than any on land, and entire mountain chains winding across the seafloor. The Mid-Atlantic Ridge, for example, runs like a scar through the ocean's center, a place where new crust is born, pushing continents apart at the rate of a few centimeters per year. The deep sea is not just a place of stillness, it is also a record of time. Layers of sediment hold tiny fossils and chemical clues that scientists use to reconstruct the planet's history. Each layer is a page in the story of Earth, chronicling past climates, extinctions, and shifts in ocean chemistry. To study the abyssal mud is to read a diary written over hundreds of millions of years, each entry written in silence. And perhaps most hauntingly, the abyss may hold the remains of things long forgotten. Fragments of meteorites, ancient microfossils, even the traces of human history, ships, cables, and remnants of exploration rest side by side with the planet's oldest rocks. Time gathers everything here, preserving it beneath a veil of darkness. The creatures that inhabit these plains are often strange and otherworldly. Some, like the Dumbo octopus, move gracefully with ear-like fins, as if flying through an invisible sky. Others, like amphipods and sea spiders, live slow lives, surviving where almost no food remains. Scientists have discovered species here that have changed little for millions of years. Living fossils that offered glimpses into ancient oceans long vanished from the surface. To think of these plains is to confront the vastness of our planet. We often imagine the ocean as a surface, waves, currents, blue horizons. But in truth, the ocean's true heart lies in its depth. Beneath the restless skin of the sea lies this immense, quiet realm, the foundation of the living world, where the planet's memory rests. In the end, the abyssal plains are not barren wastelands, but places of patience. They remind us that life endures, even in silence, and that the Earth's beauty is not confined to light and warmth. There is wonder, too, in stillness, in the slow dance of sediment, and the faint glimmer of unseen creatures moving through eternal night. Here, in the deepest calm of the world, life whispers rather than shouts. The ocean keeps its secrets well, but not forever. Bit by bit, we are learning to listen. The last light beneath the waves, the journey through the ocean's deepest secrets, is not one of discovery alone. It is one of humility. We have touched only a fraction of what lies below. More than 80% of the seafloor remains unmapped, unseen, and unknown. It is a reminder that, even in the age of satellites and space exploration, the greatest mystery still lies beneath our own planet's surface. Down there, beyond reach, the ocean moves to a rhythm that is slow, eternal, and indifferent to time. Creatures live and die without ever knowing sunlight. Mountains rise and crumble in silence. Whole ecosystems thrive in places we have never named. And perhaps that is the true beauty of the deep, that it does not need us to exist. The ocean is its own universe, self-contained, self-sustaining, serene. It asks for nothing but respect and stillness, an acknowledgement that we are guests here, temporary observers in a realm that has existed for billions of years and will continue long after we are gone. As we return from these depths to the light above, we bring with us not conquest or mastery, but awe. The ocean's deepest secrets remind us that there is peace in mystery, beauty in the unknown, and meaning in silence. The ocean has always been more than water. It is the planet's memory, its breath, its dream, and even though we cannot see its heart, we can feel it, pulsing quietly beneath every wave.